Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS8792, Cryptography and Network Security, Unit 3, topic Public Key Cryptosystem. Public key cryptosystem, there is some source A that produces a message in plain text x is equal to x1 x2 dot dot xm. Here the m elements of x are letters in some finite alphabet. The message is intended for destination B. Here the B generates a related pair of keys, a public key PUB and a private key PRB. PRB is known only to B, whereas PUB is publicly available and therefore accessible by A, with the message X and the encryption key PUB as input. Here it forms the ciphertext y equal to y1 y2 dot dot yn, y equal to E of PUB comma X. Next, we are going to see some diagrams for the public key cryptograph system. That means in the position of the matching private key, it is able to invert the transformation. Here the adversary observing Y and having access to PUB but not having access to PRB or X must attempt to recover X. It is assumed that adversary does have knowledge of the encryption and decryption algorithm. If the adversary is interested only in this particular message, then the focus of effort to recover X by generating a plain text estimate X. Next, we are going to see the public key crypto systems authentication. In this authentication, it shows you have to prepare a message to B and encrypt it using A's private key. Before transmitting it, B can decrypt the message using A's public key. Because the message was encrypted using A's private key, only A could have prepared the message. Therefore, the entire encrypted message serves as a digital signature. In addition, it is impossible to alter the message without access to A's private key. So, the message can be authenticated both in terms of source and in terms of data integrity. Next, we are going to see the public key crypto system authentication and secrecy. That means we have to begin as before by encrypting a message using the sender's private key. This provides the digital signature. Next, only we can able to encrypt again using the receiver's public key. Here, the final ciphertext can be decrypted only by the intended receiver, who alone has the matching private key. Thus, confidential is provided. Here, one disadvantage of this approach is that public key algorithm is more complex, must be exercised 4 times rather than 2 in each communication. Next, we are going to see some of the applications for public key crypto system. Encryption or decryption, that means the sender encrypt a message with the recipient public key. Digital signature, the sender signs a message with its private key. Signing achieved by a cryptographic algorithm applied to the message or to a small block of data that is a function of the message. Key exchange, 2 sides cooperate to exchange a session key. Several different approaches are possible in the private keys of one or both parties. Next, we are going to see the requirements for public key cryptography. It is computationally easy for a party B to generate a pair key. And it is computationally easy for sender A knowing the public key and the message to be encrypted. It is computationally easy for the receiver B to decrypt the resulting ciphertext using the private key to recover the original message. And then it is computationally infeasible for an adversary knowing the public key and a ciphertext to recover the original message. We can add a 6th requirement that it is not necessary for all public key applications. Next one is public key cryptanalysis. A public key encryption scheme is vulnerable to a brute force attack. The countermeasure is the same using large keys. Here the another form of attack is to find some way to compute the private key given the public key. There is a form of attack that is a peculiar to public key system. It is an essential for a probable message attack. Thank you.